Welcome back. This is Mr. Hassan's Maths channel, and I am now going to be going through question number 6 from the Mechanics M1 October 2024 International A-Level Edexcel exam. And here we have a question, part A of which is about statics. And it says a particle of mass 5 kilograms lies on the surface of a rough plane. Okay, so we have a rough plane, which means we're going to have to deal with friction here. The plane is inclined at an angle alpha to the horizontal, where tan of alpha is 3/4. The particle is held in equilibrium by a horizontal force of magnitude h newtons, as shown in figure 4. So the horizontal force acts in a vertical plane containing a line of greatest slope of the inclined plane. What does that mean? As many of you ask, well, imagine you're looking at this angle at the plane. You would see something, kind of making it three-dimensional. You would see like a plane, and you'd see this particle P on the plane. What they're saying is that basically the force that's horizontal acts kind of in a vertical plane. Okay, this is a vertical plane. It acts basically in line with that vertical plane. It's horizontal, right? So it's like not an angle. It's not like going at an angle to that. It's in line with this slice, basically. Okay, that's what it basically means. If you don't really understand that, it doesn't matter. It really doesn't matter. Okay, because basically the forces are drawn there for you. All right, then it says the coefficient of friction between the particle and the plane is 1/4. And we know that the coefficient of friction has been given a symbol, which is mu. So mu is equal to 1/4. Find the smallest possible value of h. We'll find the smallest possible value of h, okay, such that this thing is in equilibrium. Okay, the first thing I'm going to discuss is the way that the force is drawn. This horizontal force is keeping this object in equilibrium. Now, what I like to do is basically I like to take the force acting horizontally and just put it on this side. So that's what I like to do. It just makes it a bit easier to work out certain angles and to picture it. So I just take this force and I get rid of it. Okay, I'll get rid of what it says on this side and I just switch it to the other side. It's the same thing, right? No difference whatsoever, just a bit easier to deal with. So that's what I've done over here in this diagram. Okay, I have just switched the h from that side to this side. Now, what we're going to do is we're going to think about the situation here. Let's think about the forces acting on P. Okay, the forces acting on P are the weight of P, acting vertically down. The reaction force, H, of course, which is already drawn, and also the frictional force, which is acting. Now, which way does the frictional force act? That's what we're going to think about. Okay, so this is the reaction force. Some to me pen. Second, this is the reaction force. This is the weight. The weight is 5g newtons. It's 5g. Okay, and we have the component of the weight. I'll just get this ready for the components of the weight. Okay, now, how do we deal with the situation now about the friction? So this thing is in equilibrium. So we have to understand that it's in equilibrium. Okay, so it's not moving, it's still. But we want to find the smallest possible value of this force h. Okay, so if the h was any small, if the h was not there at all, what would happen to P? It would slide down the plane. So this h is just about preventing it from sliding. It's like it's about to slide down the plane, and H is preventing it. Okay, H is preventing it. Okay, the biggest possible value of H would be such that it's about to slide up the plane. It's just about to slide up the plane, but it's still in equilibrium. Okay, that would be the biggest possible value of H. But the smallest possible value of H is just small enough. It's like it's got the smallest possible value that you can have, and this thing is in equilibrium. If H is any smaller, it will slide down the plane. Okay, it will slide down the plane if H was any smaller. And if it was the opposite situation, if it said the biggest possible value of H, it means, you know, the biggest possible value of H such that this thing is still in equilibrium. Means it's just about to slide up the plane. And if you increase H anymore, it will slide up. Okay, so this is the case that we first mentioned, the smallest possible value of H. So this thing is just about to slide down. If we reduce H any more than this minimum value, P is going to slide down. So if it's on the point of sliding down, that means the frictional force is going to be acting up the plane. So in this case, the frictional force is going to be acting up the plane, and because it's on the point of sliding, okay, the smallest possible value of H will be such that it's on the point of sliding down, we'll have achieved F max. F max is achieved when the object is moving or it's on the point of moving. And that's the scenario that we have to think about for the smallest possible value of H, because if H becomes any smaller, it will move. So it's on the point of moving. So it's on the point of moving down. Okay, so therefore the friction acts up. Okay, it's opposing the motion. So now we have this angle as alpha. I'm going to resolve the 5G newtons going into the angle and going away from the angle. Okay, so parallel to the plane and perpendicular to the plane. So if I think about this, make it a bit better. If I think about the weight and I want to resolve the weight in the direction going, oops, the wrong arrow. In this direction, I have to go into the angle. I have to go into the angle given, so I have to use cosine. So this is going to be 5G times cosine alpha. You can think of it, we're finding the adjacent side. Okay, this side here. Okay. And we also want to resolve the force parallel to the plane. So that was perpendicular, this is now parallel to the plane. Okay. So what we can say is that we have to go away from the angle given. Okay. We have to go away from the angle given, so we're going to use sine. It's going away from the angle given alpha. So we're going to use the sine ratio. I don't know, rotate, do you 1 second? Okay, that's better. So that's going to be 5G times sine alpha. Okay. Now for alpha, we told in the question that the tangent of alpha is 3/4. So by now we should be used to this, how to deal with something like this. We want to give things in exact values as much as we can. So tan of alpha is 3/4. Now remember, the tangent of an angle is the opposite side to the adjacent side in a right angle triangle. And in this right angle triangle, if this is the opposite, this is the adjacent, the hypotenuse is going to be 5. 3, 4, 5 triangles, as we know. Okay, so even without drawing a diagram, we could understand that if this is opposite, this is the adjacent tangent, and the third side, there's a hypotenuse, is going to be the sum of the squares of these two sides. Okay, so we can see that it's going to be 5. 3 squared plus 4 squared equals 5 squared. So we can say the sine of the angle is opposite over the hypotenuse. This is the hypotenuse, so it's going to be 3/5. And the cosine of the angle is the adjacent, which is this 4 divided by hypotenuse 5. So those values of sine alpha and cosine alpha will be useful for us in this questions such as this. So now we also have the force H that needs to be resolved parallel and perpendicular to the plane. Now what we know is that this is horizontal, this is alpha. This angle must be alpha by corresponding angles, like the F shape. So if I want to resolve this force in the direction which is perpendicular to the plane, I'm going to go away from the angle. So in this case, I'm going to use h times sine of alpha. And if I want to resolve the force in the direction which is parallel to the plane, this would act upwards, and that's going to be h times a sine of alpha. Sorry, cosine of alpha. Why? Because we're going into the angle. It's like we're finding the adjacent side, and here it's like we're finding the opposite side. So now I have got all the forces resolved parallel and perpendicular to the plane, and I should be able to answer the question now. So let's go ahead. So now let's resolve the forces first perpendicular to the plane. We have R is equal to 5g cosine alpha plus h times sine alpha. Okay, so we know cosine alpha is 4/5, so R is going to be 5 times g times 4/5. Okay, and plus h times the sine of alpha, which is 3/5. So the 5's cancel here, so we can say the reaction force is equal to 4g plus 3h over 5. Okay, so that's the reaction force. Now, if we resolve the forces going down the plane this way, because it's about to slide down, okay, so I'm going to take that as positive. It doesn't really matter which one I do because it's an equilibrium. So we have 5g sine alpha, okay, is equal to, because it's an equilibrium, F max plus h times cosine alpha. Okay, so let's change what we know. So now I know F max is equal to mu r. Okay, F max is equal to mu r, and mu is equal to a quarter. You know, mu is equal to a quarter. Okay, we want to find what h is. Right. So what I can do is I've got 5 times g times sine alpha. That's 5 times g over 5. That's going to be 3g. That's that's going to give us, because that's 3/5. 5's cancel, 3g is equal to F max, which is a quarter, times R, which is 4g plus 3h over 5. Okay, that's basically 3g, which is this, equals F max plus h times cosine alpha, which is 3h over 5. Okay, h times cosine alpha, which is going to be, cosine alpha. My bad there. Cosine alpha is 4/5. So it's going to be 4/5 of h. Okay, so that's F max. Okay, and that's basically, the other force acting up. Okay, so 3g must be equal to all of that. So now we have everything that we need. We have basically h is the only unknown. Okay, so what we can do is we can say 3g is equal to, that's a quarter times g, which is g, plus 3 over 5, 3 over 20 h plus 4 over 5, which is the same as 16 over 20 h, right? Okay, just to get ready to add these together. So we have 3g minus g equals, and when I add these together, I get 19h over 20. So that leads us to, this is going to be 2g times 20, that's 40g equals 19h. So therefore we can say that h is equal to 40g over 19. Okay, so we can work out the value of that if we want to. So we have 40 times 9.8 over 19. And that gives us 392 over 19, which is equal to 20.6 or 21. So you can write this as 21 or 20.6. Those are perfectly fine ways of expressing your final answer. So that's the answer to part A of this question, which is all about statics. Now, part B of this question is about dynamics, about the object sliding down the plane. So I'm going to save that in a separate video, so I can save it under a separate topic of dynamics. So if you'd like to see that other video and all the other videos from this paper, click on the link at the top right of the screen. If you'd like to see other papers dealing with this whole topic of statics, okay, and limiting equilibrium, you can look at the playlist over here. You can subscribe to the channel by clicking on this link, and at the top here you will have a link that takes you to a video where I explain how you can use my channel efficiently. Thank you for watching, and see you soon.